Take a look at this bracket that we have. There's a lot of extra material that seems to be there, but it's hard to know where to take the geometry away. Topology optimization is a great way to use physics to figure out what the end result of the model should look like in order to keep as much structural integrity in the model, but by reducing as much weight as possible. Here you can see a result we have from topology optimization within ANSYS. As we take a look at this, you can see it's removed a lot of the extra geometry. But we might want to make further edits to the design to prep it for additive manufacturing. You'll notice it took away a lot of the geometry within the pads. We see that we might want to smooth some areas out. And also you'll notice some inconsistencies with the STL file. Some triangles are inverted and we have overconnected edges. This is no problem for SpaceClaim. We can easily go through and autofix to repair a lot of the common errors that occur in STL files. But we can do more than just that. We can take and actually merge real geometry back into the model to add material back to the STL file. This can be invaluable when trying to edit and make changes to an STL file. And last but not least, we can do a shrink wrap on a model. What that means is we'll use a new STL file to wrap a blanket over this design. Now you'll notice in this part is we've probably removed too much detail by the model with our current gap size. However, what we can do to make this a little bit finer is go through and actually use the original geometry that was prepared and presented to us and choose a secondary size for key locations. By using 1 millimeter at these key hole locations, we can use that for our true tight mesh in these areas, and everywhere else will gradually expand to 5 millimeters. Here you can see we have a nice tight faceting here and gradually grow into a coarser 5 millimeter mesh around here. But that's not all. If we want to do further changes to the model, we can do additional smoothing. And smoothing is really simple. We can either reduce the triangle count and do a local smooth on the model. Increasing the angle threshold will actually go through and break sharp edges on the design. Or we can do an approximate smooth, where we actually add triangles into the design to further smooth the model. With just a few simple tools, you can drastically smooth and clean up STL files from topology optimization to feed this directly into a 3D printer. Thank you for watching.